Impala. Now, Impala is given by Cloudera. Okay, so this is a Cloudera module or Cloudera distribution. Cloudera has created Impala. What is the difference between Impala and Hive? So Impala is not open source because this is you're getting all in this distribution if you're working with GCP or AWS or Mappa, you don't get this. In Hortonworks nowadays, because Hortonworks and Cloudera is a single company, you can avail this Impala distribution and you can use it. So we'll quickly compare between Impala and Hive. So Impala is giving you the fast start. This is giving you the cold start. We'll find out the reason why the Impala is more fast compared to Hive. And by the way, all that query which I was doing in Hive, I can easily do that in Impala. This is giving me the cold start because it checks so many things. It checks the driver, then compiler, then your meta store, then again go back to compiler, submit the query to execution engine, perform all that operation, come back to interface. In Impala, their Impala daemons is already available, already ready. So in Impala, where I submit my query, that daemon is known as Impala D. The daemon is known as a Impala D, Impala daemon. If I write in bracket, Impala daemon. Hive, we have execution engine as MapReduce, right? Or I can use other execution engine also, TZ or Spark. So let me talk about this too, because we have seen this MR in TZ. Impala is doing massive parallel processing. Impala's the internal concept is based on MPP, massive parallel processing. Hive is doing data pre-processing, transformation, so kind of ETL jobs Hive is handling, right? Because if I have some query which are long-running query on ETL, and maybe they're running for 1 day or 2 days. So say I'm taking data in a billions, and I'm running query on that data. So Impala is not fitting on those query because Impala is not a fault tolerant. Impala is not a fault tolerant. What do we mean by fault tolerant? If any of the node is failed while doing this massive parallel processing, because here also we are doing with a multiple cluster. So wherever my Impala D is set, my query is running. If any of the node goes down, that complete operation will fail. Again, I need to resubmit that query. But in Hive, we have all the data nodes because this is storing all the data in HDFS, though they are also storing data in HDFS. But fault tolerance is not available in Impala, whereby Hive has that fault tolerance. So we can say Hive is a fault tolerant. This is in-memory processing. So they built a cache. This Hive is not in memory. This is a disk operation. If it is MapReduce, but yes, if it is a TZ, then I can handle this as in memory again. That is the reason the popularity of Impala has been decreased because we have got other execution engine. In fact, your Spark can also run a query and access data from Hive. We'll see that in Spark SQL part, how Hive can be managed from there. So if I go to see the Impala architecture, we already know this Hive architecture. Let's go and see Impala architecture. So this one image which I'll open for Impala, and we'll see all the component here. So this is your Impala component. Hive meta store, Impala state store, which means where Impala is storing their data. So Impala is storing data not in separate space, it is in HDFS only. Where Impala is storing their metadata? Impala is storing their metadata to RDBMS, PL/SQL, MySQL, Oracle, okay, any database which you can take. Let's say in our case, currently this is MySQL. So Hive is also using this two thing, HDFS and MySQL. Impala is actually not separating your output or your metadata. Impala meta is store. Okay, this is the important point. Impala meta is store or Hive meta store is same thing. So Impala is pointing to the same meta store where Hive points. And for data location, Impala also points the same folder where Hive is pointing. So it's like if I'm creating one table in Hive, I can access that table from Impala. If I'm creating one table in Impala, I can access that table from Hive. Then why do I need this Impala? For especially for this query, DML operations. I'll give you the example so that we can relate. If I submit insert query in Hive, so we know that MapReduce job is going to call. It will take some number of mapper, reducer if it is required. It will take a reducer also, especially for aggregation query such as group by, order by, cluster by, distribute by, sort by. In Impala, any of this DML operation is not running on MapReduce because this is not built on top of MapReduce. This is built on top of their own daemons. Okay. So query time is very less in Impala, but again remember, if I have large number of query, if I'm extracting data from my HDFS and they are so big, then this Impala can give me two problems. First, if all the data is not fitting in memory, then it will give me memory out of bound exception. Second, if any of the machine fail in between while running the query, then this Impala entire result or entire query will fail, which is not the case of Hive. So anytime my choice is Hive, but yes, if I'm giving my demonstration to business, right? Suppose we are working with a UAT. So development task is done, SIT is done, and we are representing some table to our client. Now, suppose I have just got half an hour to check all the table. If I'm running query on Hive, it is going to take a time. So can I run the same query in Impala and can do the job in less time? So time wise, we'll compare. Uh, 2 point which is important. Impala and Hive both are using same meta store to keep their metadata and same data location to keep their data. So that what table I have in Hive can be visible or accessible from Impala and vice versa. Hive Metastore, Impala status score is actually checking all the health of Impala daemons. This is checking all the health of Impala daemon. Suppose I have 5 node running and on all 5 node I have Impala daemon installed, okay, or configured. So this Impala status store will ensure that what is the health condition of all the 5 nodes. It is going to run a query or read or write the output in HDFS just like Hive. How many option I have in Impala? So I can open Impala cell from terminal. I have my Cloudera open. I'll open this Impala cell. I have another option I can open from Hue also, which is the interface. If you're writing some program in IntelliJ or Eclipse, then you can connect using this client driver also, JDBC or ODBC client, and Hive Metastore. This is another option. Impala daemon. So this is what I said. If you have 5 machine available and you have configured Impala daemons in all the 5 machine, so Impala is running on all 5 machine. This is just one example. We have configured this in 2 machine. This is one machine. Let me say node number 1, and this is another machine which is node number 2. In this both I have installed Impala daemon. So who is checking their health is a status store. Then Within this, we have query planner, query coordinator, query execution engine. This execution engine is a Impala daemons. Okay. Then it is storing their data to HDFS, and I can run query on HBase also. So just like I'm saying, whatever table is available in Hive can be accessible from Impala. Similarly, whatever table is present in HBase, I can access that data also from Impala. When we start HBase, we'll see that option if required. So these two machines are there, they're coordinating with each other, and there is a main coordinator. Just like we have name node as a master machine, there is a main coordinator which will coordinate between their query. So why they're faster? Again, because this is in-memory based operation. And for first time, if I'm running any query, they'll take a time to cache. Your caching is only for one time. Okay. Suppose I submit a query, select a star from table name where this is the condition, or maybe insert record in this table. So what will happen? That query will read the data from disk in the case of Hive. In the case of Impala, first query is also reading from disk only and then caching in memory. So my first query can take some time, because whenever you say caching, right? Let me write the caching step. If you say your system is based on in-memory or caching, so not immediately they cache. First, they will build the cache. So when you run a first query, it will take some time. If I submit the same query again, if I submit the same query again, then it will not take much time to read the data because this is already cached. So let me explain this way. If I'm saying select count star from table name, we know this count star is a DML operation. Count star from table name. So first query it is taking, let's say, 14 seconds. Then again I'm submitting the same query. That time it will just take 2 seconds, because when I submit this query first, they're building the cache. Then second time when I'm running the same query, the cache is already built. It is just reading from there. And well, this cache is always a volatile. Volatile means they're storing on temporary basis, not a permanent storage. Permanent storage is your disk. So much theory. Let's go and run some query on Impala. To open Impala cell, okay, to open Impala cell, you have two options. One, you can open from terminal from here, and uh, sudo hive you will not type. Okay, now hive is a separate uh, interface. Here I will type Impala hyphen cell. Once you type Impala hyphen cell, this is open. So databases. Now whatever database is present in Hive, this is displaying us here. Can we validate? So along with this terminal, I'll open one more terminal so that we can do a quick validation. Okay. Sudo hive. So if somebody knows Hive already, Impala is very easy. It's not a new module for them. Query is 99% same I'm using in Impala. The query is not different. I will validate one by one. Database first and then table. So databases. So default may PRWN SERDI. Okay. Can I go to any database and check the tables? Then I'll see the result. Select star from GDP 20. This is the result. I'll go again to this database. So tables, select star from GDP 20. First time it will take 1 second. Unsupported type date in May GDP. Okay, so date is not supporting in Impala. I have one database name as date here. Let me take another database which does not have a date column, date data type. Remember, read the error. It is saying that date data type is not supported in Impala. So that's one point to note. Select a star from customer. Let me take customer star. So first time this query will take little extra time because they are building the cache. Okay, so cache building takes time, and this is how my output will look like. This is somehow formatted output I'm getting here. If I'm running the same query here, so let me go back to this. So tables, select a star from customer. By the way, this is not a DML, okay? This is just a DRL. Can I run a DML operation here? Like insert a query or maybe a count operation. So if I'm running a select count star from table name, okay? Remember this time, okay? My first query took me total 9.57 second in Impala. If I run the same query again, they are taking just 3.36 second. Why? Because first time they are building the cache, second time the cache is already built, they are reading that data from the cache. As soon as I go out from this Impala cell, my cache will be deleted. Well, this is the cache concept. Now I will do one DML operation. So count star from customer. This I'm running in Hive. This is a data manipulation because I'm doing aggregation query here. Run this and run the same query in Impala also. Select count star from customer. How much time? Since the cache is already built for this customer, the result is in 0.51 second. 4 times 9 is your number of row. Exactly. Just cell are different. Syntax is 99% same. One syntax is different. I will tell you that syntax. Only one syntax. If I want to refresh the table in Hive and if I want to refresh the table in Impala, that one query is different only. You can see it here in Hive. When you submit this DML operation, they submitted this to MapReduce, which is a disk-based operation, and then they'll take a time for reducer and mapper. This will take close to 1 minute. Okay, output is this. In fact, more than 1 minute. 80.616 second. If I run the same query again, they're not any cache concept. So it will take the same time again, 80 second or maybe 78 second. But this is, if I run anytime this query, they'll take in fact less than a second. Okay, it's not even a 1 second. So this is how your Impala or in-memory processing is working. Now, can I access this? And by the way, whatever insert I was doing there, joining concept, all the query which you have submitted in Hive, the same query, I can check it here in this Impala. So if you want to practice more on that, since the query is same, I'll not uh, spend more time there. I'll go and open a tab. I'll share this file with you guys. Impala practical example. So there's an official page by Apache. The first link, impalaapache.org. You can click on this link and all the practical examples are there with Impala. So query, since Hive query and Impala query is same, uh, I'll not run all this query again. We know already Hive, how to check Hive, how to work with Hive. So please go with this URL and check some of the query, how much time they're taking and how much time your Hive query is taking. And by the way, if you're working with a MapReduce, then only you need Impala. What in the case if your execution engine is already TEZ, which is way faster than Impala, then obviously you don't need Impala. That's the reason Impala is like, if you know Impala today, that's okay, added advantage. If you don't know, that's also fine, because you can say that my execution engine is TZ and I do not need this Impala, right? Because this is also in-memory processing. We have seen the flow of TZ in Hive, where they take less time to create the vertex. Now, this is one space to check the Impala. Second space, I can open my Q terminal and check it from there also. So both the option we'll see. Create database. So this is Impala, and let me run some query. Create database. DB1. Now this database should be visible in Hive also. If it is not visible, we have to refresh our uh, table or database. Okay, so databases. DB1 is visible. You can check it here. Let me go to DB1 and create one table. Create table sample with column 1 and type string. Enter. Now can I see this table in Impala? So use DB1. So tables. Currently this is not giving me because they take some time to sync their metadata. Okay. So invalidate table name, which is sample. Sorry, invalidate metadata. Can I check now? Yes. Sample 1 is there. Now if I take any data and write that in the sample from here, from there, all I can see, because already I have mentioned the point, Hive, Impala both take the same location for metastore and same location for data. So they can access each other table and uh, metastore. But my choice, if I'm running long running queries, it is based on the application. Okay, I cannot say Impala is favorite for me or Hive. This is based on the application, what application we are working with. Open this browser to check one more option. So once this is open, you can click on this hue. In the query editor, you'll find it has selected by default Impala. There's two options. You can either go with Impala or Hive. Let me click Impala again. Okay. So all the database table is present here. I can go to in fact DB1 also and check the table, the structure. There is a refresh button given to you. Okay. So if you have created some table in Hive which is not visible in Impala, or you have created some database in Hive which is not visible in Impala, then you can click on this sign. What this sign is doing internally. So this is the refresh button just looking at this, I can say. But internally in Impala, this refresh button is running this command, which I have submitted in my cell. What did I submit? Invalidate metadata table name. What they do, they will refresh all the metadata which are present here, in Hive. So let me write the case actually. Note, case number one. If Hive DB or table is not appearing or visible in Impala editor or cell, then run below command. And what is that command? Invalidate metadata and table name. So this refresh sign, this thing is doing what internally? They're running this query only if I refresh it. Then second point, vice versa. If Impala, if table created by Impala cell or editor is not visible, not visible in Hive cell or editor, then run below command. What is that command in Hive side? MSCK repair table and table name. MSCK repair table and table name. Now when you go to Hive editor, okay, let me change this editor from Impala to Hive. So this is changing to Hive now and change to Hive. So if I click on this Hive and the database which I have created in Impala is not visible, I'm running again this refresh button. Or if table which I have created in Impala is not visible here, again I'm running this refresh button. So this refresh is doing what? This refresh is running this thing internally. Yeah. So this is how Impala and Hive can be connected to each other using very simple basic architecture. They do massive parallel processing because they are fast. Just one reason I will tell you, they're not dependent on MapReduce and they are separately running their query on Impala daemons, but they're not fault tolerant. When I work with a big data space, I need this fault tolerancy option. This is one of the one major reason. Okay. In nowadays, okay, new Impala, I was just doing a study, so I found one more new point. So just thought to include that also. In new version of Impala, what they said, if your memory is, if your memory size is very small, which is not able to fit all the data set, then we can spill over some data. Then we can spill Spill means what? Data spilling we call. Okay. So let me first tell you data spilling. We have seen this in MapReduce also, by the way. So data spilling is what? You see map 0%, reduce 0%, right? When your query starts or job submit. Then you see map 33%, reduce 0%. What does this mean? Can I read this in English? Map 33%. 33% means whatever data set you are processing. Let's say this data set volume is total 100 GB. Okay, this data set which are stored in HDFS is 100 GB. So out of 100 GB, 33% task from the mapper is done, which means 33 GB map task is done. And this data has been spilled in your disk. Spilling means writing the intermediate output in the disk. That's what is called as a data spilling, or data spillover we call. So 33 GB of this is done. Suppose I'm saying 25% of reducer, this is also done in 25%. Likewise, they're keep processing. So that's what we're getting when I submit that query on Impala or Hive, right? Suppose this is my Hive. When I submit this query, I'm saying map 100% done. What does this mean? This is nothing but a spill. 100% spill means all the data is queried and written in HDFS. By the way, this data is present already in HDFS, so I'm just scanning this information. But when I'm extracting from a scoop, or when I'm processing using MapReduce or any other programming model or language, and I see this mapper percentage this or reducer percentage this is nothing but a data spill. Okay, so spill is only available. This concept is only available in disk computation model. This is not available in-memory processing. But Impala has brought, just like a Spark. Spark has also this point along with the in-memory. So Impala says if your memory is 4 GB, if your RAM is 4 GB, and this is full, you do not have uh, any more space available to write or to write the in between cache or data from the table, then you can write some information on disk so that you can avoid that memory out of bound exception. So you can write some information on disk that processes spill process, data spill process. So this is the new added point in Impala. I think in last year, 2019, we get this Impala spillover point. Well, in real-time industry, I do not find more number of company who are working with Impala. People who are working with Cloudera, Impala is by default given by Cloudera. So yes, if you want to perform fast operation, you can definitely use this, especially for demonstration purpose. So depends on the use case. That's on Impala side.